All right, some other types of equations are absolute value equations. So we can look, let's start with a basic. Okay, so absolute value equations. Okay. If we had to solve the absolute value of x is equal to 5, well, we know that there are two solutions to this. We know that x is equal to 5, or the other possible solution is that x is equal to negative 5. That's because the absolute value of 5 is 5, and the absolute value of negative 5 is also 5. So what's happening here is that there is a distance away from 0 that we're looking to be. So graphically, if we were to solve this, the absolute value of x is a v, and it has a 45-degree angle here. So this is y is equal to the absolute value of x. So if that's my left-hand side of the equation, I can draw a line through here. This is the line y is equal to 5, and I would have two intersection points, and these would be the solutions, the x values at this point, and the x values are 5 and negative 5. So now, when we look at the absolute value of 6x plus 4 is equal to 8, now there's an unknown distance in here. Okay? We don't know exactly what x is, but we need for this distance to be equal to 8. And so the way we can do that is that it's either that what's inside of our absolute value, in this case the 6x plus 4 is equal to 8, or we get a second solution when what's inside the value is equal to the opposite here. So in this way, I can just solve the linear equations that 6x is equal to 4, or dividing by 6, x is equal to 2/3. Okay, so that's one solution. We could also have that 6x would be equal to subtracting 4, negative 12, and dividing through by 6, then that x is equal to negative 2. Let's do our check. So is it that the absolute value of 6 times our x plus 4 is equal to 8? And I'll prep it over here as well. Okay, so this is what we're asking ourselves. And in this case, we'll check 2/3 first of all. Okay. Remember, this is like 6 over 1. We can do some canceling. 3 goes into itself once, and into 6 2 times. So 2 times 2 is 4, plus 4. And yes, this is true. The absolute value of 8 is equal to 8. So x equals 2/3 is a good solution. Now we can check x equals negative 2. We'll have the absolute value of negative 12 plus 4. Does that equal 8? And yes, the absolute value of negative 8 is equal to 8. So both of these check. Let's try another. We could have the absolute value of 3x plus 4. Now minus 4 equals 6. Okay. Now notice what we had here in this situation is the absolute value was isolated. And so that allowed me to use this reasoning for distance to split it up. Here we have a problem though, because this -4 is attached to the absolute value. So I need to isolate the absolute value. And to do that, I'll add 4 to both sides. So this is the absolute value of 3x plus 4 must be equal to 10. Now that the absolute value is isolated, I can use that reasoning about a distance from 0. So it's either that what's inside the equation, or the absolute value, is equal to the positive, or that what's inside the absolute value is equal to the negative. And now we can solve these. So this is 3x is equal to 6, so x is equal to 2. Or we have 3x's is equal to -14, so x would be equal to -14 thirds. There's another case. We could have that the absolute value of something, in this case, the absolute value is isolated, will be equal to 0. So since it's isolated, we can split it up. -5x plus 10 is equal to +0, or that what's inside is equal to -0. But there's no such thing as positive or -0. There is just 0. So in this case, we only have 1. So we can solve this. And so we see that x must be equal to 2. And you could put it back in. -5 times 2 is -10. -10 plus 10 is 0. And the absolute value of 0 is 0. We could also get an equation like this. The absolute value of 3x plus 4 is equal to -9. And this should cause us some problems. The mere fact that this is equal to a negative number is not possible. Absolute value is always positive. So in this case, there is no solution. And let's go back to Desmos so I can show you what that would look like graphically. So let me clear these out. Okay. Now we have the absolute value of 3x plus 4. Yeah, 3x plus 4. Okay. That's our V-shaped graph there. Okay. Now we would like, that's the left-hand side, and what we have on the right-hand side is -9. I think I have to put that in as y equals -9. Yeah, there we go. So there's the horizontal line y equals -9. Here's our left-hand side of the equation. This graph and this graph do not intersect, so there is no solution to this equation. Okay, so those are some absolute value equations. Okay. Now, there's also equations that come in quadratic form. So for example, this is, let's see, we have 3x to the 4th minus 2x squared minus 1 equals 0. Okay. Now this is a 4th degree equation, so it is not quadratic. However, it is quadratic in form, because I could think about this. If I pick a new variable, let's call it u, if I let u equal x squared, well, if I square both sides, I would have u squared is equal to x to the 4th power to power. So what that tells me then is that this is really 3 times u squared minus 2 times, well, I said u was equal to x squared, minus 1 equals 0. And now, this equation is quadratic, no longer in x, but in u. This is known as a u substitution. Alright, now we could solve this. I think this will factor 3u and a u. Only choices are 1 and 1. Minus 3 plus 1. 3u squared minus 3 plus 1 is my guess. Okay. And now I can solve because it's factored. So it's either that 3u plus 1 equals 0 or u minus 1 equals 0. So 3u's is equal to negative 1, or u is equal to negative 1/3. From here we see that u is equal to 1. So we solved the quadratic equation in u, but we were asked to find what x is. So to do that, we have to back substitute, and we said that u was equal to x squared. So we really have that x squared is equal to negative 1/3, and that x squared is equal to 1. Now I can solve for x. If I take the square root of both sides, I will get x is equal to plus or minus the square root of negative 1/3, or x is equal to plus or minus the square root of 1, which is 1. So we really have 4 solutions here. 2 of them are real, and 2 of these are complex. So let's do just a little bit of manipulation here. We know this is the square root of negative 1 times 1/3. So this is plus or minus the square root of negative 1 times the square root of 1/3, which is plus or minus, and the square root of negative 1 is I. And we can split the radical up here. This is the square root of 1 over the square root of 3. So this is plus or minus, the square root of 1 is 1, I over root 3, which we could rationalize this denominator, and we'll get plus or minus I roots of 3 over 3 are our other 2 complex solutions. Okay, let's try another one. Okay, so this was quadratic in form by doing a u substitution in this way. Okay. Here's another one. We could have x plus 2 squared plus 11 times the quantity x plus 2 minus 12 equals 0. We could again do a u substitution. If we let u equal x plus 2, then I could rewrite this as u squared plus 11u minus 12 equals 0. And will this factor? Yes, this will factor. Okay. So this will factor into u plus 12, u minus 1. So it's either that u plus 12 equals 0 or u minus 1 equals 0. So u is equal to negative 12 or u is equal to 1. And so we've solved for u, but that wasn't our goal. The goal was to solve for x. That's okay. U is equal to x plus 2. So really it's that x plus 2 equals negative 12, or u plus 2 equals 1. I'm sorry, x plus 2 equals 1. So it's either that x is equal to negative 14, or x is equal to subtracting to negative 1.